Anne McKendry. I'm on the faculty in the Division of Plant Sciences, and I'm a wheat breeder and a geneticist. So our work involves developing varieties for farmers in Missouri and the surrounding states, any place for which those varieties are adapted. And our research involves looking at some of the traits and doing genetic analysis of some of the traits that are useful to us in the plant breeding program. What we are standing in front of here are segregating populations. When we start a wheat breeding program, we start with a cross between two parents. And in crossing those parents, we're trying to bring together the traits that are valuable to the grower that come from each parent. They're not always in an individual parent, so we have to use a breeding strategy in order to bring those traits together. This population and others down this field are populations that have been developed from a cross between two parents. And so what you see here is not something that is uniform, but rather something that is showing the various traits that were in the parents as they sort out. These populations have been sorting out for about 4 years now. That's one of the breeding strategies that we use. And so you can see clearly that they're sorting out for things like height. They're sorting out for things like the presence or absence of awns or the beards on the wheat. So here we have an awned one, and here we have ones that are awnless. They're sorting out, as you'll see in the plot, for disease resistances. So one parent was resistant, one was susceptible. So in our offspring, we have plants that are resistant or susceptible. So we're interested in bringing those traits, the resistant trait, into the population. And there are several diseases that we work on. One is Fusarium head blight. It's a disease that both kills the grain and produces a toxin in the grain that renders it unmarketable. So we are interested in trying to develop wheat varieties that have a number of traits. One is that they're early maturing, because Missouri is a double cropping environment. And so growers would like to have wheat out before they put their soybeans in, and the earlier that happens, the better. At the same time, we want them to yield reasonably well. And unfortunately, early maturing varieties very often don't yield as well as late maturing varieties do. So we're looking for that elusive combination of both early maturing and high yield. And that's actually one of our main breeding strategies. We're also looking for varieties that are shorter in stature, because growers don't want to have to deal with the long straw that's associated with tall varieties. We are looking for varieties that have better disease resistances, because disease takes away from yield, or in the case of scab can render it unmarketable, the grain unmarketable. And so we are looking for resistance to head scab or Fusarium head blight. We're also looking for resistances to diseases that take away the leaf canopy. The green part of the leaf is the part that produces the yield. So the greener it is, the more yield we have. If it loses its canopy to diseases, the plant is unable to photosynthesize as effectively, and consequently we don't get as much yield. So we're looking for resistance to diseases. We're looking for shorter plants. The presence or absence of awns is something that is up for negotiation sometimes between myself and my technician. Growers tend not to like the awns as much. In the olden days, they used to stick to them before the days of air-conditioned combines. But they, in some climates and in some circumstances, actually, because they are green and photosynthesizing, contribute to yield. So we really don't select for or against awns. Now, most of the varieties that we have released happen to be awnless, and many of the soft red winter wheat varieties are awnless. So that's what we would be looking for. So when we go through these populations, what we're going to be doing with them is choosing plants, choosing individual heads. And so an individual head has enough seeds on it that we can then advance this into a plot situation over the period of 2 years. And we're going to look at where those come from in just a moment. But the seeds on this head that I have chosen here are the seeds that will begin the investigation of a new line or new variety. The seeds on this head have the potential to be a new variety. This is all the seeds we have of it, and so we have to increase it in size, increase the number of seeds, and ultimately, if it meets all of our criteria, it will become a variety that will be released to the grower. Now, we can't assess yield in this situation because every plant is different from every other plant. So we have to purify each plant we select, increase the seed of that, and then evaluate it for yield in another stage of the program.